This is a video to show the operation of a dip switch calculator which performs addition, subtraction, ANDing, and ORing of two 4-bit numbers. In this, we have one dip switch located here. That this first section right here performs addition. This is flipped down. Second one's flipped up, performs subtraction. This one's flipped down. Third one flipped up, it will perform ANDing. And the last one flipped up will perform an ORing operation. The output result will show with 4 green LEDs, followed by 1 carry bit and 1 negative flag. This is the two input numbers, which will perform the 4 binary bit individual inputs, which will then be input through the Nucleo board. For this operation, you still have the two 4-piece 4-switch dip switches, which will do the first input number and the second input number, followed by the other 4-switch dip switch, which will perform the operation. The first one perform adding, subtracting, ANDing, and then ORing. All the inputs are put through PC0 through PC11, and then all the outputs are run through PA4 through PA9 using 220 ohm resistors to eliminate green flags as well as the carry flag, negative flag. So for actual functionality of this, there's a flow chart. So initially the program will initialize, it will use the RCCs, initialize each monitor for A and C GPIO pins as well as the pull down resistors. Initially it's going to define the variable A by logically shifting the bit left 4 times and mask the unused bits. And then it's going to define variable B using the same input and then mask the extra bits used in variable A. For the indication of the input operation, the while loop is going to determine an if statement, which is going to detect input on GPIO C. In this case, if it's 001, the input is shifted left 8 bits, additional bits that are unused are masked, and then determines if the sum of A and B is going to be performed, and if the value is greater than 15, it's going to then output the value on PA4 through 7, which will be illuminating the 4 green LEDs in whatever instance that the result comes to, as well as illuminate the carry flag on PA8. If the sum is not greater than 15, it's going to do a normal operation, where it's going to output the sum value on PA4 through 7 on the normal LEDs and then no carry. Over here, if the subtraction switch is pressed, it's going to take that bit position, it's going to shift it left 8 and then mask the unused bits, and it's going to go into a little loop here where it says is A less than B. If A is less than B, then it has to convert it from the unsigned bits to signed using 2's complement. And then what we do is we not A and B, then we add 1, and then we XOR with 0x200, which allows us to have the negative flag on. So it outputs the difference value on the green LEDs and then illuminates the PA9, which is a negative flag. If A is not less than B, it will just output the normal difference on PA4 through 7 with no flag. When the third position switch is flipped up, it'll shift the bits 8 to the left, mask the unused bits, and then output the bitwise operation of A and B on PA4 through 7 with no additional flags. And lastly, the GPIO-C input for 8 will be shifted to the left 8 bits, mask the unused, and then it will perform a bitwise OR operation on A and B with no additional flags. Each one of these will correspond after each function is done to then repeat back at A, which is right here. And as far as the actual program goes, it's written in C code, where you can see that the initial clocks were turned on. We clear the pins for GPIO-C and then enabled the pull-up resistors, and then also too, clearing these pins allowed for input for GPIO-C mode registers. We clear the pins out for the output for mode register A, as well as turned on the individual outputs for PA4 through 9. This uses a main while loop, which it will shift the actual bits A and B. This will shift A left 4, and then it will mask the unused bits, and then the variable B will mask the unused bits that are covered by A. So you'll have the input of switch 1, shifted left 8 as previously discussed, the basic operation of A and B, and then it will determine right here if we have a carry flag or not if it's greater than 16. Correction, 15. For subtraction, we have the input for GPIO-C. Again, we'll shift the bits left 8 logically right here, and then we're going to mask the additional bits right here. This determines in this statement if A is less than B. In this case, we're going to use the tilde sign to not the difference of A and B, and then add 1 for a 2's complement, and then we're going to mask the unused bits. Then we're going to XOR it with 0x200, and that will give us the normal value followed by a carry flag. Otherwise, it's just going to perform a normal operation if A is greater than B. For the ANDing operation, it's pretty straightforward. We're going to take the input, we're going to shift it left 8 bits logically, and we're going to mask the unused bits. For this operation, it's going to do a bitwise AND operation, and there's no carry and there's no negative flag. For the last one, we're going to have a GPIO-C input, shift left 8 bits right here, and we're going to mask the unused bits, and we're using a basic bitwise OR operation. Further function of this, we're going to start with the addition with the first switch pressed up. We have no lights illuminated, and we're going to do a basic 1 plus 1, which is binary 0001 and 0001. So with the first switch is pushed up, shown we're having a value of 1. When we add the next one up, we should have the second light illuminate only by itself, which it does. We followed by this, if we want to add 1 plus 3, we're going to push this up, so it's a binary 3 plus a binary 1 should be a binary 4, which should be the second bit is illuminated. And if we could do binary 3 plus 3 would be 6, which should illuminate the third and the second light, which is what we have. And you can continue on if you want to show 7 plus 3 should give us the 10, which is the 8-bit, as well as the 2-bit, which comes to a sum of 10. To perform a subtraction, we clear all those out, turn off the addition, and turn on the subtraction by flipping the second bit up. Performing subtraction, so normal operation would be, the first number would be 4, which we're showing 4, minus 2, which would be an output of 2. And then we could try also another normal one, which would be 8, which is the first one, minus 1, which would be 7. Additionally, you clear them all out, and we could try a negative operation. So we'll do 2 minus 4. So 2 on the first number is going to be the second light, minus 4, which is third switch, which comes out to -2, so negative flag as well as the second bit. Additionally, we could try a subtraction operation of 2 minus 3. So there's 2, and there's 3, should give -1. As you can see, the first bit is eliminated and a negative carry flag. Turn them off, and then turn on this. You turn on the ANDing operation, which is this is going to take the input for the 1 value, turn the first flag up to 1. 1 ANDed with 0 is going to be 0, but 1 ANDed with 1 will also be 1. You can also do this for the other operations. That'd be 1 and 1 will be 1, and then 1 and 0 will be 0. Turn these off, and you could try it likewise with all 4 up is nothing, and all 4 up on the first input is all 4 lit up. The last operation in the bit for bitwise is going to be ORing, which is going to use the same two inputs as a table. For the input of 1 and 0 will be 1, as well as 1 and 1 will also be 1. You can also do this for any other bit here too. We have 1 and the second place is going to be 0, shows us 0, plus and 1 is going to be 1. And you can do this for all 4 as well. All of them up will be 1 and 1 equals all 1s with no carry bit as well. You turn them all down and you still have the input value of 1, and 0 will give you also 1. Lastly, you forgot to cover the addition with a carry bit. So you flip that up and you flip up all 4 of these. We're looking for the carry bit, which is the blue LED to illuminate. So right here we have 8 plus 4, that'll be 12, plus 2 will be 14, plus this is 15. In order to get the carry bit, we add 1, which has a carry of 1, which brings us to 16. And that shows the operation of the addition of the carry bit. You can try that also with, let's try to get 8 plus 8. So 8 plus 8 is the same thing with the carry bit.